In this video, we're going to be looking at solving quadratic equations. So the learning objective here is to be able to solve quadratic equations using a range of strategies. And the success criteria here will be that you'll be able to solve quadratic equations using a variety of techniques, such as grouping, completing the square, choosing two integers with the required product and sum, and the quadratic formula. Now we won't do all of these in one video, but we will be looking at these through a sequence of videos. So the first thing here is we need to think about what we do know about solving equations. So we know that if an expression or an equation is equal to 0, then we know that at least one of the factors of this expression must be 0. Now recall that we actually call this the Null Factor Law, and what it does is it helps us to solve a number of mathematical expressions. Now if you think about what the Null Factor Law tells us, it tells us that if the product of two numbers is 0, then at least one of the numbers must be 0. Now, relating this back to quadratic equations, how the null factor law relates is that if we are given a quadratic equation, we then write it in standard form, and the standard form would be y equals ax squared plus bx plus c, and from that we can factorize the equation. We can then apply the null factor law to help us to then go on and solve this quadratic equation. So let's start with something nice and easy, which is to solve the following equation. So here what I'm going to do is factorize this particular equation. So let me just make them all equal to 0, except for that one. So we're going to factorize the first equation. So that will be a common factor of x, leaving us with x minus 3 is equal to 0. So now separating this, so null factor law tells us that one of the factors must be equal to 0, must be 0 in order for this equation to be true. In this case, x is equal to 0. Then we've got x minus 3, making that equal to 0, leaves us with x is equal to 3. So our two values of x, which make this equation equal to 0, is when x is equal to 0 and x is equal to 3. I'm going to do the same for question 2, except this time our highest common factor is a. So now we've got question 3, which says 3m squared equals 75. What I would do here is divide out the coefficient of m squared, which is going to be divided by 3. That will leave us with m squared is equal to 25. Now here you need to be very careful. When we square root 25, m can actually be two solutions. It can be positive 5, or m can equal negative 5. And it's important that you acknowledge that m can be both. Remember, the reason being, if we square positive 5, we will get an answer of positive 25. And if we square negative 5, we will also get positive 25. Hence why m can be 5 or it can be negative 5. Now you might be wondering, what do we do if it's in the general form, which is the ax squared plus bx plus c. So what we can do here is apply our understanding of factorizing expressions in order to help us to solve the equation. So let's start with something nice and easy. We've got a monic trinomial. What we're going to do here is factorize this. So we're going to have x plus 1 and then x plus 1. Let that equal to 0. So all of these again are equal to 0. So now I'm going to basically do x plus 1 equals 0, leaving me with x is equal to negative 1. Now the reason we only have one solution is because x plus 1 is a perfect square. So let's go have a go at doing question 2. So this one here is a non-monic trinomial. So we can employ two different strategies to help us factorize this. I'm going to use the cross multiplication method for this one. So my factors of 10x I'm going to choose will be 5x and 2x. And then my factors of negative 3, I'm going to choose a 1 and negative 3. Now cross multiplying these, I'm going to end up with the following, which is negative 15x and 2x. So now adding these two together, I'm going to end up with negative 13x. which means my linear factors will be 5x plus 1 and 2x minus 3 equals 0. So now applying null factor law to solve for x, I'm going to do the following. And my solutions are for these for this particular equation is for it to be equal to 0, x would equal negative 1 on 5, or x will equal 3 on 2. So now moving on to the last equation. So this one's a little bit trickier. It's obviously not in a form we're used to seeing. So what I would say to do is rewrite it so it is. So how I'm going to do that is by multiplying the denominator out. So that'll leave me with x plus 6 is equal to x squared. So that's taking this, multiplying it by x, and multiplying the right-hand side by x. So now I'm going to rearrange this so that the whole equation is equal to 0. So I'm going to bring the x squared inside, or to the left-hand side. So now what you can see here is that a is actually negative 1. So in order for x squared to be positive, I'm actually going to factorize this by taking out a common factor of negative 1. So that's going to basically transform my equation into the following. Now dividing the 0 by the negative that we factorize the equation by is going to leave me with the following. And now I can factorize this trinomial. So I'm going to have x minus 3 and x plus 2 as my factors. So now applying null factor law here, x minus 3 equals 0, so x could equal 3, or x plus 2 equals 0, so therefore making x equal to negative 2. So hopefully now you're feeling a little bit more comfortable with solving quadratic equations. And in here you can see that we've used a range of strategies that we've actually looked at prior when we were looking and learning about factorizing equations.